Welcome back, dear students. In last class, we studied about syllabus of second module, second chapter, and after that, we studied a little bit about definition of compaction and what are the effects, very important effects on compaction that we study. Now we are going ahead with the complete understanding of this compaction. See, whenever you take a soil, this soil will have particles, the soil will have some particles, and soil will also have some moisture in it, that is the water, and soil will have some air voids in it, and all three together it is called as soil. This you already know in the first chapter. For the study purpose, you can make it as a three-phase system of soil. This also explained in our previous classes. That is a solid phase. This is a solid phase, and there will be some water separately kept. This water, this is the water phase, and after that we put some air in it. There will be some air in it. This is a air phase. Okay, all these three phases together, it is called as a three-phase system of soil. Three-phase system of soil. Now this three-phase system, in it we are studying the compaction chapter, means we are going to compact this soil. We are going to compact this soil. This soil, what happens when we compact? That in the definition you already know, we reduce air voids. We remove, instead of reduce, we will say we remove air voids. When we compact here, by means of what? By means of rolling load, or by means of tapping, or by means of vibration. Whatever you use, or all together you can use, and by doing that you are going to reduce the volume here. When you reduce the volume of air, then initially the volume will be this much, and later the volume will be reduced. Then this much is reduced. This is a reduced volume. See, this reduction is only because of air. The reduction of this volume is because of air only, not by water, not by solids. This you have to keep in mind. Okay. Then volume is reduced. Then what happens to the density? Density is a mass by volume. Then volume is reduced. What happens to the density? Before that I need to make some conclusion on this mass. This mass, what happens? When we do compaction, air is escaped, therefore mass will not be altered, because air don't have any mass, therefore particles are not gone away and water is not gone away, therefore mass will be remains constant when you do the compaction. That is, you got it. And after that, volume reduces means what? Density will increase. Okay, this is called as ideal compaction. Keeping mass constant and compacting to increase the density is called as ideal compaction. Why it is called as ideal? Because practically we will not achieve maximum density by doing this, because it is impossible to remove all the voids. Therefore, to have a better compaction, what exactly we do? Just think here. You take some dry soil, imagine a powder. Okay, this is a dry soil, just like a powder it is there, and after that you need to compact it. Will you be able to compact it to its topmost density, to its highest density? No, it is not possible. Then when I ask you to compact it, the first thing you do is you add a little amount of water. I am using the word little amount of water, right? You are adding little amount of water so that the compaction becomes very good. Then when you add a little amount of water, then there will be some property change, that particles will get some cohesion, they will attract each other, therefore it becomes very easy to compact. Then you added little amount of water means what? The mass is increased. Wow, the mass is increased means what? See, mass is increased means density is increased, but volume is decreased means the density is increased. But volume, why it is decreased? No, because when you add a water, then volume is also increased, and that mass is also increased. Once again, you take some amount of soil in the tray and the soil mass is 1 kg. The soil mass is how much? 1 kg. What will be the volume of that one? Volume might be about 500 centimeter cube. See, the volume is 500 centimeter cube and mass is 1 kg. Then when you add a little amount of water, what happens to the mass? Mass will increase. Let us take 1.2 kg of mass. Then volume is also increased. It might be 550 gram of 550 centimeter cube of water, soil, 550 centimeter cube of, see, mass is also increased and volume is also increased. Now how you conclude on density? Mass by volume. Mass is increasing, so that the density is, sorry, volume is increasing, thereby density is decreasing. Mass is increasing, thereby density is increasing. See, you are not able to make any conclusion on density, because mass increasing, density must increase, volume increasing, density must decrease. Then you don't have any conclusion on density. Therefore, the scientist named the Proctor, he invented one test. That test is called as Proctor test. Briefly, I will explain that what that Proctor test is. Then later I will go to the what exactly the test is done on that soil. Okay, that Proctor test is all about adding water and getting checking its density. Let us consider here only I will explain. So take about 10% of water, add to the soil and compact it. Check the density. 15% you add, compact it, check the density. 18% you add, check the density. 20% add, check the density. 30% add, check the density. Like that, he is playing with the soil. He is just increasing every time he is increasing water content, means moisture, that water added, that is increasing, and he is just checking the density. He observed something very very interesting, that increase or decrease in the density. Initially he got increasing in the density, later he saw some decrease in the density. This I will leave it to you, that why this decreasing is happened, why it is increased, why it is decreased, that you need to think. That information I already gave you, that by adding water, volume also increases, by adding water, mass also increases. But initially why this is increasing and later why it is decreasing, that you think. Okay, at the end of the video if you want I will explain it, but now we'll go to the Proctor's experiment, how he did, what he did, and that we will understand. There are two types of tests based on Proctor's study. That is, one is a standard Proctor test. It is also called as light compaction. This is called as light compaction. The another one is modified Proctor test. That is also called as heavy compaction. That is called as heavy compaction. Now in this Proctor test we are going to determine two parameters. One is OMC and second one is MDD. Very important two parameters we are going to check. According to Proctor, in last slide I told you that by adding water content, different water content, he checked with the dry density, various dry density check, and he got a conclusion that initially with some water content the density will increase, later with some water content, increase in water content, density decreases. Means somewhere one peak will be observed. No? This peak density is called as maximum dry density. This is a peak density above which you don't have any density. See here, the density is increasing and it reaches one peak, and that is a maximum dry density, and after that the density is decreasing. Obviously it is a maximum, and when it is achieved at a particular water content, this is achieved at a particular moisture content. This is observed at a particular moisture content. That moisture content is called as what? That moisture content, I cannot say that it is a maximum moisture content. I cannot call this as a minimum moisture content. Therefore, I am using the word optimum moisture content. Optimum means nor too high nor too low, but it is that condition where you are getting dry density as a maximum. Therefore, that is called as the optimum moisture content. Definition is a water content at which soil can be compacted to its maximum density. Right? Then maximum dry density, the definition is the maximum possible density that can be compacted when optimum moisture content is added. Okay, this is called as standard. This is a aim and objective of the standard compaction test. Then what we do in this compaction is we will be having one mold here. This mold is called as compaction mold. This mold, for your exam purpose, you can draw it in this way. This is the wall of the mold. It is in circular shape. You can see here this is the circular in shape and like a cylinder, and its height is represented here. Its height is 12.73 mm centimeter, 12.73 centimeter or 127.3 mm, and its diameter is 10 centimeter. Its diameter is 10 centimeter or 100 mm, and there will be one collar here. This is called as a dolly, or we can call it as a collar in common language. Okay, this is a it has a detachable plate. See here some screws are there here. By using these screws you can detach this upper part and lower part and even the base plate also. You can detach it. Here you can see the screws are given here. Okay, by using that, then what exactly we do? There are some dimensions, not only these dimensions, whatever the mold you are using, that dimensions you will be knowing. And after that, one hammer will be there. See, this is the hammer. This is a hammer. What's standardly designed? Here you can pull it out, and when you pull it, it will go inside where you can drop it from the top. Means you can pull it and you can drop it from the top. Okay, when you drop it, this plunger will come and hit to the soil. This plunger will come and hit to the soil. That is called as blows. That is called as blows. Okay, blow. That is called as blows. Then the procedure, here you can see there will be some molds here. This is one mold. We can say this is a 1000 centimeter cube mold, and some big mold is there here. This is a 2250 centimeter cube mold. We can have a two types of hammer here for compaction. This is a 2.6 kg hammer, and here I can have even a 4.5 kg hammer also, depending on the requirement that you are going to study in the later classes. Okay, and obviously we require one weighing balance, and the soils also we want. Okay, now going to the procedure, what we need to do is we will have two different types of mold for the test. Okay, obviously just I explained that is one is 1000 centimeter cube mold and second one is 2250 centimeter cube of mold. Sir, which one we need to take? That is a question mark. That is depending on you. That I explained here. Farmer mold means this mold. This mold is used to such soil which has more than 80% of the soil passing through 4.75 mm sieve. You take the sieve size 4.75 mm, put all the soil. If you have more than 80% of the soil passing through 4.75 mm, then you take 1000 cc mold. And latter mold means what? This mold you can use it when the soil is more than 20% is retaining on 4.75 mm sieve. In that case you are going to use this mold. You got a clear idea when to use out of these two molds. Then after that, known quantity of O1 dry soil. O1 dry soil means before starting the experiment, take the soil and put into the oven for 24 hours and 110 degree plus or minus 5 degree centigrade temperature. After 24 hours you bring the soil, a known quantity about 2.5 kg of soil you need to take if you are using a small mold, and you need to take 5 kg of the soil if you are using a big mold on the tray. Okay, let us consider this is a tray and you take a soil that told here. Then after that, known quantity of water, say 12%, you can start it. Known quantity of water means you take a measuring jar, in that one you take a 12% of water. Say for example, if you are using a 2500 grams of water, a 12% of this one is 0.12. The whatever that answer comes, that much ml of water you are going to take as a water. Okay, and that water in the tray soil is there. This water you put it and compact, not compact, you just mix it thoroughly. Okay, very well. Take about 5 minutes time. Just mix it very thoroughly. You just mix it. You should get the homogeneous mix. Then after that, the mixed soil is to be compacted in the mold. 3 equal layers, one by one. Say this is a mold that I already shown. The one base plate will be there, some fixing arrangement will be there. Here the tray is there. Here in this tray you make a 3 part of the soil. Take one first part of the soil and put in the mold and put here, and by using that hammer you compact it. Okay, then after that bring the second layer and put it here and compact it. Put the third layer and compact it. This you are going to do. Okay, one by one you are going to compact, giving 25 number of blows. There is a standard here. You cannot compact it day and night. Okay, throughout the day, throughout the night you cannot compact. The first layer when you put, you need to drop down that hammer for 25 times. Okay, lift it and drop it, lift it, drop it, lift it, drop it, like that 25 number of times. If you are using 1000 centimeter cube mold, if you are using 2250 centimeter cube of mold, then you need to lift it and drop it for 56 number of times. For small mold, 25 number of times. For big mold, 56 number of times. Then there is again a standardity here. You cannot drop it and drop it from the very higher height. That is not possible. That is not permitted. You need to drop it from 310 mm only. See, this is the first layer. Take that hammer weight is 2.5 kg, and that hammer you need to drop it from 310 mm for 25 number of times for small mold and 56 number of times for the bigger mold. Doing this, you complete the test. Then that you measure on the weighing balance and get the mass of soil. Mass of soil you are going to get. Understood? The first experiment is done. First trial is done. The same thing, the test is repeated for first what you did for 12% you did, and later you add 16% water, 20%, 24%, so on. You go on adding the water and doing the test. Okay, and after that you need to draw the graph. That graph is, say this is the water content that you already for trial for explanation I consider 12% and 14%, sorry 16%, 20%, 24, 28, 32, like that you go on adding the water content and check the dry density. How to get the dry density? Because you will be knowing the mass of the soil, and mold height and diameter is known, though, therefore you know the volume of the mold, therefore you got the density. But this density is a bulk density. You want a dry density. Dry density is equal to bulk density divided by 1 plus W. This W is given here. Then you will get a dry density, means dry density list is also here. This dry density and water content, you bring it on the normal graph. Here you will get the moisture content in x-axis and dry density in the y-axis. Then you will get this nature of curve. In this one you will get the top point. The top point indicates maximum dry density, and that corresponding water content is called as optimum moisture content. Over. You achieved the required data. Once again, pause the video, go back and just observe the video, you will come to know. Thank you very much. This is called a standard Proctor test. In the next video, we are going to study the heavy compaction. Okay. Thank you very much.